Okay, good day, Sir Amora. We are Group 1 and we are gonna be reporting CubeSat and small satellite communications. So, this presentation is presented by Alcasid, Almira, Buenaventura, Icawat, and Lumagui.
Talk about the two closely related space technologies, the small satellites and CubeSat. Let's start. What is a small satellites? Imagine you're like sending package. You have big boxes, medium boxes, small boxes, and tiny parcel, depending on what you need to deliver. That's how small satellite works. They come in different sizes. The mini satellites weigh 100 to 500 kg, like our large boxes, and microsatellites, nanosatellites, and picosatellites are for like tiny parcel that weighs less than 1 kilogram. Small satellites are used for Earth observation, communication, weather, and science experiments. They're cheaper, faster to build, and can be launched alone or with bigger satellites. They can hitch a bigger mission. It's like carpooling in the space. They're helpful in disaster response, agriculture, environmental monitoring, and bringing internet to the remote areas. Now let's go to the CubeSats. CubeSats are like this, the special kinds of small satellites. Think of them like Lego blocks in space. CubeSats, each CubeSats is a cube called 1 unit, like 10 by 10 by 10 centimeter, and you can stack them uh, depending on the mission, like that. It can be 3 units or 6 units. They were made to make space more affordable and accessible, especially for students, researchers, and startups. And they are now used by NASA and other space agencies too. Even though they're small, CubeSats can take Earth photos, collects data, test new space tech, and used in education, science, and communication missions, and even deep space missions. In summary, all CubeSats are small satellites, but not all small satellites are CubeSats. It's just like Lego blocks are toys, but not all toys are Lego.
So now let's talk about why cube satellites or those small satellites are called to be part as of emerging technologies. So here in the slide we provide three reasons why it is so called. So first is the miniaturization and technological advancement. So we all know naman that before yung mga satellites are very huge and bulky, and also aside from that they are expensive. So now we can able to build a very small pero powerful na satellites. So it is possible because of the availability and miniaturization ng electronics. So just like sa mga phones natin, so they become smaller and smarter. So now we can able to fit a lot of features using those miniature na electronics in a tiny CubeSat. So it makes it easier and cheaper para masend them sa space. Another reason is the commercialization ng space access. So yung space natin is no longer those that can be only accessed by those so-called big government agencies like NASA. So now different private companies are known like SpaceX and Rocket Lab that they can offer affordable launch services. So because of this, even those university and other startups, they can already afford to launch their own cube satellites. So yung space is becoming more accessible and becoming more open to everyone. So and the third one is the global connectivity and the IoT integration. So yung CubeSats are helping us connect different devices all over the world. Even how remote you are. So, yung mga satellites na to, it makes it possible to collect and send data from anywhere on the earth. And aside from that, they support the IoT, like yung mga smart sensors, GPS trackers, or yung mga farming tools, especially dun sa mga places with no stable internet connection. So with that, CubeSats and small satellite technology communications is becoming emerging technologies because they became more affordable, more flexible, and they provide a scalable features of the satellites that we never had before.
So we have the key features.
For the modular structure and size standards, CubeSats follow a modular structure where 1U refers to a cube of 10 cm per side, and this standardization allows CubeSats to scale from 3U, 6U, or even larger formats. And it can also enable the easier manufacturing and simplified integration with the launchers and lower development costs, all while keeping the size and weight manageable. And for this one, we have the modular structure of a CubeSat, which means it's built in layers like stocking blocks. And at the very top, we see the solar panels and solar sensor, which collects energy from the sun to power the satellite. Next, we have the attitude control system. It helps the CubeSat know which way it's facing in space. And we have the payloads or mission-specific tools. And for example, the satellite has tools for producing and measuring high voltage. We also have the onboard computer, which acts as the brain of the satellite, and the power system manages the battery and energy coming from the solar panels, while the communication system is what sends and receives messages to Earth using the antennas. And finally, we have the strong frame and side panels to keep everything in place. So for this one, we have the OBC as mentioned earlier. It is the brain of the CubeSat. Just like a car can't run without its engine, the satellite can function in space without an OBC. It controls the entire mission, like managing the data, processing commands, and making sure all subsystems work together properly, including the main payload. And because of its importance, choosing the right OBC means carefully checking the needs of the mission and making sure it works smoothly with all of the other components of the satellite. So in recent years, there's been a shift towards an all-in-one OBC solutions, which is the PyCube, and it was used in the Harvard satellite team. So for this one, we have the power system. So it is also vital for any CubeSat. Just like in larger satellites, it needs to generate, store, and distribute the electricity to keep the mission running. You can see here in figure 1 that it converts sunlight into electrical energy, and this energy is used or stored in rechargeable batteries to be used when the CubeSat passes through an eclipse and there is no sunlight. So the EPS manages this process and includes DC-DC converters and regulators that ensures the power is properly distributed to all subsystems and the payloads. And we have the communication system. So this image shows that it is responsible for sending and receiving data between the satellite and the ground station. And CubeSats often use the UHF, VHF, or S-band radios to transmit telemetry like health and status updates and to receive commands from Earth. And a ground station on Earth is needed to track and communicate with the satellite during its orbit. So after the launch, the antennas are deployed, allowing the CubeSat to start the communication, and these antennas are usually folded inside the satellite during launch to save space.
Nag-work sina CubeSat and small satellite communication. So, almost the same lang yung pag-work nilang dalawa, which is, ayan, si Earth is nagsasend siya ng command papunta sa satellite. So, yung mga ground stations, gumagamit sila ng antennas para mag-send ng radio signal papunta sa mga satellite. So, yung mga signals na to is nagsasabi sa satellite kung ano nga ba yung gagawin. For the second process, which is yung satellite, nagre-receive siya and nagpa-process ng mga commands. So, yung satellite kasi is meron siyang onboard computer na nagre-read ng mga commands and nagpe-prepare ng mga acts, katulad ng capturing images or measuring data. For the third one, si satellite is nagko-collect siya ng data from space. So, gamit yung mga sensors or cameras, si satellite kumukuha siya ng information katulad ng weather data, space readings, or yung mga images na nanggagaling sa Earth. And then, yung mga data na yon is nasa-store sa satellite. So, yung satellite, nagsasave siya ng mga data na yon sa memory niya until pwede niya nang isend yung mga data na yon pabalik sa Earth. So, yung fifth one is yung satellite, sinasend niya yung data pabalik naman sa Earth. So, kapag nasa range na yung satellite ng ground station, gumagamit to ng radio waves para mag-transmit ng mga istinore niya na data. So, tinatawag to na downlink. Then, yung last process naman is yung Earth, nagre-receive siya ng mga data and ginagamit niya yung mga data na yon. So, yung mga ground stations na yon is nagde-decode ng mga signal na galing sa satellite. And yung mga researchers or engineers is ina-analyze yung mga results na yon galing doon sa data, galing sa satellite.
So, ano nga ba ang real-world applications na itong CubeSats and small satellite? Una dito is yung, ah, Earth observation. So, nakikita natin dito, pwede natin ma-monitor kung ano ang status ng weather, kung ano ang, ayun, nagla-land mapping din. Instead of manual survey ng mga tao, yung satellite na yung gumagawa, which is more efficient and mas clear kasi nasa taas sila nakatingin. So, next is connecting the world. So, itong CubeSat and small satellites ay ginagamit for global internet connection tulad ng sa Starlink. Yung puro satellites nila is interconnected to each other para maabot yung mga remote locations na hindi kayang abutin ng fiber cables, which is yung mga liblib na lugar. And pwede rin gamitin sa IoT, which is, ayun, silang mga CubeSat yung nagko-communicate to each other through their communication tapos kinukuha nila galing sa mismong sensor, pinapasa sa CubeSat, pinapasa sa isang CubeSat hanggang sa dumating doon sa control center. So, ayun po.
Now, let's look at their benefits and challenges. The benefits for CubeSats and small satellites, they are much cheaper than the traditional large satellites, just like buying motorcycle instead of a car. They are faster to build and launch, which helps them quick response or rapid test if needed. They are great for education and research. They can be launched as a rideshare, just like a carpooling with bigger satellite to save cost. They can also be launched in a group called constellation, which work together to cover large areas of the Earth. CubeSats are flexible and stackable, just like a Lego blocks. And lastly, they encourage innovation and technology testing, perfect for trying new ideas in space without spending too much. But like any technologies, there are also challenges that have because they are small, they have limited power and space, which means they can only do so much at once. They usually have shorter lifespan in orbit than big satellites. They can carry few instruments, so mission needs to be very focused. Since they are tiny, they're harder to track in space, which can increase risk. Communication time is short because they orbit quickly and pass over ground station only for a few minutes. They are also risk of space debris and collision, especially with more CubeSats being launched. Lastly, they need permission to use radio frequencies to avoid interfering with other space.
So now you might be wondering how those so-called tiny satellites can do so much. So one great example is the company Planet Labs and their so-called DAV CubeSats. So this DAV CubeSats is very small and lightweight na satellites that are designed para mag-take ng photos ng Earth every single day. So unlike those traditional satellites na very big and bulky and also expensive, these doves are very small and a size of a shoebox. So even with those size, they can carry a high resolution camera that can capture a very detailed images of the Earth's surface. So how they work sa orbit. So with this, using satellites continuously orbit to Earth natin from pole to pole. As you can see from this video on my left, an active satellites of approximately 200. So the largest single launch na na-provide nila is the 88 Doves from their Flock 3P.
For the future outlook, CubeSats are becoming smarter with AI and onboard autonomy, enabling real-time data analysis and decision making. And they're expanding beyond Earth orbit toward deep space missions to the Moon and Mars, and satellite constellations are rising for global communication and IoT. New developments include in-orbit servicing, reusability, and growing use across education, defense, and industry. So the CubeSat market is projected to reach $3.4 billion by 2031, growing at a 22.4% CAGR.
Yan. So for our summary or key takeaways, yung mga CubeSats and small satellites, very tiny lang sila and low-cost spacecraft na ginagamit for communication, Earth observation, and mga experiments. So, nag-work sila by receiving commands na nanggagaling sa Earth, nagko-collect ng data sa space, and ibinabalik or sinisend yung data na yon papuntang Earth using radios and antennas. So, usually, yung mga CubeSats and small satellites na to is ginagamit dahil mas faster and mas cheaper silang gawin and i-launch kumpara dun sa mga big satellites. Then also, importante yung mga ganitong CubeSats and small satellites kasi ginagawa nila yung mga space missions na mas accessible and nagsusupport din ng disaster response sa farming, internet access, and also nakakatulong na mag-connect ng mga smart devices around the world.